Assalamualaikum. Today I will present about assignment 1 part B for digital electronic 1. My name is Muhammad Muaz bin Lotfi, metric number 211021139, and this is my other group member. The question that we got is to design a 4-bit serial in parallel out shift register using D flip-flop. In this video, we will cover about the introduction, methodology, logic diagram, truth table, results, and discussion. So, the 4-bit serial input parallel output SIPO shift register using D flip-flop. Introduction. Data is inputted serially one bit after another in serial input parallel output SIPO, which results in a parallel output. Methodology. This logic circuit uses a D flip-flop to implement a 4-bit SIPO shift register. 4 flip-flops are present. The first flip-flop receives the data input. The input of the second flip-flop is connected to the output. The output of the second flip-flop is connected to the input of the third, and so on. Assume a 4-bit word is serially entered into D1 with the following 4 bits 1011. Each word is input in D1 just before a clock pulse. For example, bit 1 input in D1 before clock pulse 1, bit 2 before clock pulse 2, and so on. The first bit 1 will be at Q1 after the first clock pulse and at Q4 after the fourth clock pulse. The second bit 0 will be at Q1 after the clock pulse 2 and will be at Q3 after clock pulse 4. The third bit 1 will be at Q1 after clock pulse 3 and will be at Q2 after clock pulse 4. The fourth bit 1 will be at Q1 following clock pulse 4. The 4 bits will stay in the shift register if the clock pulse is now halted. We are now using the shift register as a memory. As we can see, the word was input in the register in serial form bit by bit and is deleted in parallel as a whole word. In conclusion, we can state that n clock pulses are needed to store n bits, while n clock pulses are not required for output. Now I will show you the logic diagram. This is what I get by using the Logisim software. And now for the logic circuit demo.
Hi, my name is Muhammad Firdaus Ramli. For my part, I will talk about the truth table, waveform, and the discussion. I will talk about the truth table first. For the truth table, as we can see, for clock 1, Q1 is 1, Q2 is 0, Q3 is 0, Q4 is 0. As we can refer at the waveform, for clock 1, Q1 is 1, Q2 is 0, Q3 is 0, Q4 is 0. For the clock 2, Q1 is 0, Q2 is 1, Q3 is 0, Q4 is 0. Same as the waveform. At clock 2, Q1 is 0, Q2 is 1, Q3 is 0, Q4 is 0. For the clock 3, Q1 is 1, Q2 is 0, Q3 is 1, Q4 is 0. And for the last one, for clock 4, Q1 is 1, Q2 is 1, Q3 is 0, Q4 is 1. For the discussion, the application of SIPO shift register is to convert serial data into parallel data. They are used in communication lines where the multiplexing of a data line into several parallel lines is required. Real-life application of SIPO register is to output data from a microprocessor to a remote panel indicator. That's all.